thought ahead, I guess, but like, what's God, I cannot imagine.
It's a direct process. Here's the book. Here's the pieces I want to cover. Do I understand these things? Yeah, okay. And if not, we start looking stuff up and rereading and checking other sources. I'm like, okay, well, wait a minute. Rate of return. We talk about return on investment. We talk about interest rates. We can think about a set of financial transactions, both going out and coming in, and trying to figure out what an internal rate of return is for all of those transactions as a sum. So I can think of disbursements going out, payments received coming in. But that, by the way, that depends on whether I'm the seller or the buyer as to which direction is which. So we're going to actually be able to flip signs in a bunch of places depending on whose perspective we want to look from. The internal rate of return for our transaction is the interest rate. Now we're going to assume a compound interest rate. I'm not doing simple interest here, for which all cash flow out is equal to all cash flow in at a particular valuation point. By the way, I can use any valuation point I want. I could use the beginning, the end, some point in the middle, and depending on the transaction, some valuation points are more convenient than others. Most often we think of the issuance date, the very beginning, the termination date, the very end. But if we've got something like a callable bond where we don't know what the termination date is, we might use an interim date. Say, hey, if I called it today, what would the valuation point be? If I call it next year, what's the internal rate of return? And I can work this one out. If I think about a bond as a good example, I can think of the present value of a bond. Well, that's the price I paid. That's money that came out from me. And then I receive all of my coupons and my payments, and those are what's coming in. And the formula we worked out for the present value of a bond is exactly the valuation at today for a given yield and a given coupon rate. And that yield rate was our internal rate of return. I can think of a loan the same way, or an investment. let's assume that the repayment schedule for that investment or that the earnings schedule isn't regular. Doesn't have to be regular, it could be irregular. So I'm going to have payments K1 through Kn at times T1 through Tn respectively. And each of those payments coming in is a positive number. So I don't think of paying out more money at this point in time. If I want to use my standard present value, what I'd be looking for is an interest rate that makes that work. Oh, I suppose I am doing regular setups at this because I'm using V to the I as opposed to irregular ones where I'd have to separate the T1 through Tn as my exponents. And we can convert that to 1 plus I if you'd rather. And our goal is to show and use what we know about these equations to find a unique solution for this I. We might actually find more than one solution for this I, but if L is less than the sum of the K's, Kj, J equals 1 to N, then this does have a unique positive solution. If L is less than the sum of the payments, in other words, if I lose money, it's quite possible that I could have a negative internal rate of return. An example. I have $100,000 to invest. There are two banks available to me. One offers me a 20-year payment. Every year I'll get $8,718.46. The second bank offers me the same setup, 20 years, but the annual payment's $8,024.16. I'm pretty sure I know what you're going to do. If you have a choice between buying one of these two annuities for $100,000, which one are you going to buy? It's paying you $700 more a year, right? Makes sense. What interest rate am I earning on either of these? Because that might be a more direct way to figure out which one's a better purchase. Now, I did rig this example hard because the The payments are exactly the same type at exactly the same frequency for exactly the same term. 20-year payments, annuity immediate. One's higher than the other. It's obvious the higher one's the better deal. But what if one of these was a quarterly payment of $2,100 or a monthly payment of $702 or something like that? I would actually be better off computing an annual rate of return, an internal rate of return here, figuring out the interest rate I that's going to work up here. So if I wanted to do that for bank A, what would I compute? Hmm. How do I figure out the interest rate I need here? So the present value is the amount I paid. It's an ordinary annuity with a payment of 8718.46. Ordinary annuity present value is A, 20 years at my unknown interest rate. And this is the unfortunate result of that, is that I have to solve that equation for J. Cheers for technology. I'm going to do that right on here. Now we can do that a bunch of different ways. I know I'm looking for an interest rate. I know it should be positive. So I could set my window in X to be between 0 and, I don't know, 20%. So 0.2, 50%, 0.5. I could say, or I could use the solver application built in to the calculator and actually write this equation out in the solver. So notice it says the equation is 0 equals, and I really can't move to the other side. So I'm going to have to subtract the 100,000 to the other side. 8718.46 parentheses. Parentheses, let's do that way. 1 minus parentheses 1 plus x to the negative 20th. That's the top. Close that, divide by x, subtract 100,000. 100,000. That's the thing I want to set equal to 0. Now I actually have to hit solve because that's not the right answer. Alpha solve. And it gives me an interest rate. Now this is already annual payments. So the interest rate is 6%. And that's an effective annual interest rate, a nominal interest rate, because they're the same in this case. Now, how did it actually do this? Because my calculator is stupid. See that bottom line there? Bottom line says left minus right equals 0. Yes? What it's doing is it's literally using the intermediate value theorem. It's going back and forth and zooming in by a factor of 10 each time, looking for positive versus negative until it gets a value that's equal to 0. That's why this was set up equal to 0. on both sides of this number. I can do this graphically the same way. I could set this up. But if I do this, I'm going to have to change my window quite a bit. I've set the window up so it goes from all the way up to 110,000 so that my 100,000 is in the middle there, not at the very top. And then I'll have my equation of value on the other side coming down as our interest rate increases. We see they cross somewhere, find the intersection here. We should get that same 6%. Calculate intersect 6%. Make sense? Find me the interest rate for bank B. That's what I came up with. The only change is the amount from 8,700 to 8,024, and when I just put that in, I get 5%. But that was kind of obvious. I was getting more money on the exact same terms from the first bank. It should have a higher interest rate. I was getting less money from the second bank. It should have a lower one. But again, that's what's interesting here, is that this applies to any sequence of financial transactions. So let's generalize. I'm going to make sure these are in order. Usually T0 is 0. But these are in strictly increasing order. So time 1 is less than time 2 is less than all the way up to time n. And money in are going to be these payments A0 through AN. By the way, if there is no particular money in at a given point, we'll just leave that to be 0. Money out is the B's, same idea. Then I can talk about the cash flow, CK, as AK minus BK. And that's the amount received. That's money in at time TK. So at no point do I consider any of my payments A or B as negative numbers. I could have C be negative, but A and B are always positive numbers. And the direction depends on who I am. If I'm the person loaning the money, maybe that's going to be more negatives than positives. And we work it out based on whether I'm the buyer or the seller. If a transaction, and this is the interesting part, I'm thinking of a transaction as a sequence of payments, has net cash flows C0 through CN at times T0 to Tn, then the internal rate of return IRR is any interest rate I, so that the sum K equals 0 to N CK VI to the TK equals 0. It's also possible to shift this from just looking at the net cash flows to looking at the equation of value. Wait a minute. Valuation equations was chapter 1? 2? It was a while ago. I could think of cash in equaling cash out. This particular equation of value is using what valuation time? Exactly. Because these payments at time zero aren't adjusted in time at all. Everything else is brought back to that time. If you changed your valuation point, you could multiply this entire equation by the appropriate factor of VI and move it to whichever time point you wanted. Now, this does make a couple of assumptions that are different than things we did in the past in this course. I'm assuming that we're only going to be allowed to reinvest at the same interest rate. Remember, we had people who took the interest out of one account and put it into another account, and sometimes the interest rate was higher. So we took deposits into account one that earned interest, I think it was at 6%, then we stuffed them into an account earning 10%, but we only pushed the interest in there. We're assuming here that everything goes in at the same rate. So if each payment was invested in the same kind of annuity, they're all invested at the same interest rate so that we can be consistent in using just one VI all the way through here. If I were thinking about the annuity example we did 10 minutes ago, I would be saying, well, maybe at some point interest rates change, but we're not accounting for that. We're assuming that I can get that 6% all the way through, or that 5% all the way through the next 20 years. Questions? Let's do some stock exchanges. I'm going to buy some stock. At time zero, I buy 1,000 shares at $5 each. Plus, I have to pay commission to my sales agent, 2% commission. Now, this is a stock, it issues dividends. 6 months down the line, I get a dividend of 20 cents a share. $0.2 per share. But the stock price has changed in the interim. So I decide I'm going to reinvest. But the stock price went down to $4 per share. So when I buy the stock now, I pay a different price. Now, since that's a direct reinvestment, I don't have to pay a commission on it. Time two, 6 months later, I'm going to buy more shares, buy 500 shares at 4.5 per share with a 2% commission because this is a direct purchase. Time three, 6 months later, they issue another dividend, a quarter per share. And I tell my broker, I want out, sell them all, and the selling price is $5 per share. Okay. I'm going to need to keep track of a couple of different things here. Yes, ma'am.
Is it different of 0.2 or 2?
That's 0.2, 20 cents per share. So notice that I'm buying and then the dividends come once a year, but the dividends are off cycle from my purchase time. So I need to keep track of three things. I need to keep track of how much money went out, how much money came in, and how many shares I've got. So if I don't know how many shares I've got, I can't calculate the dividend values accurately. So at time 0, how much money came in? How much money went out? 5,000 plus 2% commission. So $5 per share times 1,000 shares times 1.02 to account for my commission, right? Which is how much? And I now have 1,000 shares. And I need that for the next part. At time 1, how much money comes in? How much money goes out? Why 4,000? But I'm not buying 1,000 shares. I'm reinvesting this money at shares, right? I don't know how many shares I bought, but I'm going to spend all this money on shares. So the amount of money that goes out is exactly the same as the amount of money that comes in. How many shares did I get? Aha. Plus 50 shares, 1050 shares. What happens at time 2? Aha, at what price? So how much money comes in at time 2? Did I get anything at time 2? I bought shares, right? That's money I'm spending. So there's no money in, but there is money out. That should be B1, not B0. My apologies. B2 is, it's at 500 shares, right? At 4.5 per and a 1.02 for the 2% commission. How much did I spend? And how many shares do I have now? Great. Time 3. What happens at time 3? Okay, I sell all of them, but I also receive that dividend, right? So I get coming in 25 cents per share. And then I sell my stock. Wait a minute. I don't know. Did I write it down on the selling? If I'm selling my stock, I should pay commission on that, right? My broker is going to do that for me because it's not a direct reinvestment. Did I make that note up here? Sell all stock at 5 per share plus commission. 2%. I need to keep that 2% commission on there, or my broker will be very, very upset and start to sue me. So I sell my shares at, what's the sell price? 5 per. So that's 5 times 1550 times what? It's only 2%. Oh, well, that would be money extra to me, right? I'm selling, I have to pay the commission out of what I get, right? So this is money coming in, I have to take the 1 minus the 0.02 or 0.98. Right. Yeah, that's like, wait a minute, that's way too much of a commission. By the way, again, I don't know what this number is off the top of my head, but I do know how much money I spent at this point in time. What was my cash flow out? Did I buy anything? Nope. What is the amount of cash that came in? Well, I took it out of here. I could. So what? That's another way to do this. Let me write this one down and then we'll show that one. So here, this number is the other way to do it, Joe, is exactly that. I can say that A3 is my dividend times all my stock plus the selling price of all of my stock, and my cash paid is 0.02 times the sell of the stock. And if I do that, then this number is 81.3750. This is $155. And if you take the difference, you get 79.8250. So yes, you can do it either way. Because the very next thing I'm going to do is figure out the cash flow values, right? C0, C1, C2, and C3. Okay, cash flow at time 0 was money out. And it's A minus B, so that's negative 5,100. At time 2, I'm sorry, at time one, I have what cash flow? Exactly. Because all the money that came in went right back out. At time two,
Negative 2,000.
and at time three,
Seven on 8, 2. And 52.
exactly. And regardless of which way you do it, whether you do the 79, 8250 here, or you take the 8137 minus the 155, you're going to get the same result. See, Joe, so you can absolutely consider the the commission payment as a cash flow out of the money you received, or you can consider it a separate cash payment out. So let's pick a date. What day, what time do you want to do the valuation at? Do you want to do the valuation at time 0 or at another time? Time 3, right? The beginning or the end? We can do it either way. If we pick time 0, then I've got to bring everything back to that date. Minus 5100 is at the right time. Plus 0, 1 plus I to the negative 1. I have to move that back 1. Oh, wait a minute. Let me use J here. And J would be a 6-month rate. And then minus 2295, 1 plus J to the negative 2, and then plus 798250, 1 plus J to the negative 3 should be equal to 0. That's already said equal to 0. We can plug that right into the solver, right? I can also do it graphically. If I used time 3, I need to move everything forward to 3, right? So this time, the 5100 has to go all the way forward in time. Minus 5100, 1 plus J cubed. 0 has to go forward, 1 plus J squared. 2295 has to go forward. But the 7982 doesn't. Please notice that those are the exact same equations. If I take the top one and multiply it by 1 plus J to the third, I get the second one. They're exactly equivalent. Solver. Go up, clear the equation. 0 equals. Which one do you want to use? Top one or the bottom one? Okay. Minus 5100 parentheses 1 plus x to the third plus 0. I'm not going to worry about it. Minus 2295, 1 plus x to the first plus 7982.5 should be equal to 0. And again, that's the solve from the previous one. So I have to hit the alpha and the solve button, which is right above. Enter, alpha, enter. My interest rate here per 6 month is 3.25%. which means my annual would be twice that. Maria, the textbook actually wrote it this time. They wrote it, I too. This solution is unique. Why do I know this solution is unique? I promise there's a reason I know this is a unique solution. There's a calculus reason I know this is a unique solution. This is a cubic equation. Take its derivative. The derivative of this is going to be minus 15,300, 1 plus j squared, right? The derivative of this is going to be minus 2295. I get that. And that's always negative, right? If that's always negative, then this function is always decreasing. And that means it crosses the x-axis exactly once. Poof. I just did this in the Calc 1 class last week. That's the reason I'm harping on it now. I know you know this. But that's actually a useful trick. My equation of value could be thought of as a function of the interest rate. And if that function is monotone, whether it's always decreasing or always increasing, I will get a unique solution. But that's an if our equation is monotone. Because it doesn't have to be. It is possible to create a solution where I get a situation where I get either no solutions or multiple solutions. If I have a function that's not monotone, it'll go back and forth. It might cross the axis more than once. If I have a situation where my function is non-monotone and it's either always above or always below, my roots to my equation might be complex, well, then I'm screwed. Normally, when you think of a credit card, you think of someone loaning you money. But in the same way, you can think of a line of credit as allowing for a negative balance. I can put money into this account and I can take money out. As the lender, I would see somebody giving me money on a credit line as a negative because then I can't charge them interest. I have to pay them interest. But if they take money out, then I'm charging them interest. So I want, from the lender's point of view, money in will be negative, money out will be positive. From the borrower's point of view, money in would be positive, money out would be negative. Because I would be taking money to the bank. So our view is from, at the moment, the holder's perspective, the borrower, the credit person, not the bank. If all balances, both positive and negative, earn the same rate, A is cash to the holder, B is payment to the bank. So I'm thinking of this from my perspective as the guy who has the credit line. When I borrow money, they're giving it to me. When I pay it back or when I put the money in the bank, that's a negative. I'm going to make this a 2-year plan or a 2-period plan. T0 equals 0, T1 equals 1, T2 equals 2. And at both T1, I'm sorry, both T0 and T2, the balance is 0. So let's see what happens in the following situation. Here's my cash flow situation. Let's do a valuation at time 0. So let's work out the equation of value. I need my cash flows. C0, C1, C2.
On 2.3, maybe 1.
Okay, if I'm doing the valuation at time 0, then this money's in the right place. This money needs to be brought back 1 period. This money needs to be brought back 2 periods. Notice I've written this in V rather than in I. You could just as easily have written this 1 over 1 plus I and 1 over 1 plus I squared. But if I write it like this, it looks like a quadratic equation. It's quadratic, solve for V. Now, the thing that bothers me about this quadratic is I wrote it in the wrong order. I put the V squared at the end instead of at the beginning, but I can still do the quadratic formula because I'm not sure how to factor this sucker. And when I do that, what happens? Because 2.3 squared minus 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 is a negative number. This never works. There's no interest rate that will allow this to be a valid equation of value with an ending balance of 0 and a starting balance of 0 at time 0 or 2. So what's going to happen if I actually do this is I'm going to end up owing money at one of these points. I'm either going to have an outstanding balance at 0 or an outstanding balance at 2 to adjust this. But if I want to try and get that to be a balance of 0, it doesn't work. All right. Ready for the huge tweak? A0 is 0. A1 is 2.3. A2 is 0. B0 is 1. B1 is 0. B2 is 1.32. Huge difference, right? Again, I'm going to end up with the only difference in the cash flow right here. And that means the only difference in my equation is in that quadratic term. What happens this time? What are they?
You're. You're one minute.
Okay, let's actually be more precise. Because if I look carefully, these are infinitely repeating decimals, right? Um, yes?
Yeah, but I don't get. The way I did it wrong, I get 0.1, not 0.2. Is that wrong?
No, I think you're right. I think I wrote it down wrong. Let me double check.
I know.
No,
you say that.
negative 1.33, 2.3, negative 1. You're absolutely right. But that's even more appropriate because then this is actually the fraction 10 over 11. And this is actually the fraction 5 over 6. What's the interest rate that goes with those? Because those are V, and V is 1 over 1 plus I. So 1 over 1 plus I is 10 over 11, means 1 plus I is 11 over 10, and I is 1/10, or 0.10. And similarly here, 1 over 1 plus I is 5 over 6, 1 plus I is 6 over 5, so I is 1/5, or 0.20. So there are two different interest rates that work here, 10% and 20%. All I'm doing is tweaking this last value, and I get wildly different results. We'll do one more. What happens in this quadratic? I'm 100% cheating here. I have the quadratic formula built into the calculator. Negative 1.2825 x squared, 2.3, and then negative 1. Again, I see repeating decimal in that first one. It even tells me in this program that I've used E and F. So I'm going to say, hey, what's E as a fraction? What's F as a fraction? 20 over 27 and 20 over 19. What are the appropriate interest rates that go with this? One of the situations I have here gave me a negative internal rate of return. That value is bigger than 1. My discount rate, V, is bigger than 1. My interest rate is negative. I am 100% cheating here. I did all of this at time 0. The textbook does this same example using the valuation point at time 2. They get the same results, but they set up the equation differently. It doesn't matter. That's a benefit here. Questions? There's a dramatic assumption made here that the interest rate applies equally to positive balances and negative balances. I know 100% of the time that if you owe the bank money, they're charging you a whole ton more than if they owe you interest. Anybody got a checking account that earns interest, savings account that earns interest right now? My checking account earns interest. Do you know what the interest rate is on my checking account per month? 0.01%. So I earn 1,000th of a cent per dollar. Yeah, that's helpful. Sorry, 1/10,000th of a cent per dollar. So if I'm lucky, I'll make a dime this month. Depends on what my balance is for the whole month. So realistically, that's not often the case. Practice on interest rate out versus interest rate in is almost always different. So our internal rate of return isn't a perfect measure here because of real practices. On the other hand, I could look at actual closing balances behavior. If I pay or charge 10% on balances in the bank, it's negative numbers here, then I can figure out what the balance in the account is at each point in time. At time 1, I put in 1 at time 0. If I earn 10% or get charged 10%, that'll be the balance. I then take out money. Well, it's positive in the interest. That means the balance right at the moment is 1.2. My first example. What was the last payment?
When you say first example, you.
The first of the 3 that I did here. What was the cap? Okay, so if negative 1.33 balances the account to 0, then I want to set up the equation of value for that. 1.33 equals 1.2, 1 plus the interest rate for the second year. Notice I've changed my notation here just a little because I'm only thinking about the time from 1 to 2. I sub 2. What's that interest rate?
11.
Which certainly wasn't a solution available to me in that question, right? Because the question stated that balances earned 10% period, both in and out. And if that's not going to work, if this were to clear the balance, I would have to get a different interest rate, 11%. The only difference in any of these was the cash flow on the third thing, the end piece. The best option for me, the person with the line of credit, is the one that has the lowest payment. If I want to clear out the balance, I should hope that I end up here, right? But notice that the interest rate that works here is 35%. That's ridiculous. That's one of the highest rates. The other rates were 10 and 20 or imaginary. So internal rate of return is not a perfect measure of preference. It is a good measure of preference, but it makes some dramatic assumptions, and that really plays into the reality of the situation a little bit differently. If my first payment, C0, is the only positive one, and all the rest of them are negative, or the other way around, the first one is negative and all the rest are positive, they're the same situation looked at from two different perspectives, then I am guaranteed a unique solution. If C0 positive and CK negative for 1 less than or equal to K less than or equal to N, then we have a unique solution for the internal rate of return that is at least bigger than -1. So it's possible we could have a negative internal rate of return. The only way I can guarantee that that's actually going to be a positive number is if the total of all of my payments is negative, including payment 0 in this situation, because that'll look like an amortized loan. So I can't use internal rate of return alone, especially if I have varying rate behaviors. Even when both in and out have unique rates, this might not be enough to guarantee me a uniform internal rate of return. But 35% seems like an awfully high interest rate. There's some actual laws about what are appropriately outrageously high interest rates, and that's part of what got us into some of the lending problems we saw earlier. More on that on Thursday. I will see you all then. A wonderful rest of your day.